Hello. In this video, we're going to go over the algebra topic that we just started in math. Some of you were not able to join us on Zoom or had audio problems, so I'm going to recap the stuff that we learned about algebra in this video. So pause it if you need to see anything again or rewind. You know what to do. So if you were there or if you've seen this before, you know that I introduced this with the question that I get all the time. I don't know why. About how old am I? Well, stay tuned to the end of the video and I'll finally reveal how old I am. But for now, as I mentioned, I am not going to tell you. So when you don't know something in math, we like to refer to it with a letter, usually. And usually that letter is going to be the letter X, but really it can be any letter or symbol that you want. There's no rule about what it is. But traditionally, X is used. So I'm not telling you how old I am. I'm going to say that I'm X years old. But if I ask you this, how old will I be in 5 years? You still can't tell me with an actual number, but you could say this, X plus 5. What if I ask you, how old was I 7 years ago? Well, once again, you can't give me an actual number, but you could tell me X minus 7. How old is somebody who is 3 times my age? Well, they're 3 times X. And I already told you that this looks a little bit weird, 3x, x with a little time symbol. So we're not going to even use this little time symbol anymore. We're just going to say 3x. Or we could say it like this in brackets. This also means 3 times x. How old is somebody who is half my age? Well, they would be x over 2. How old is somebody who's 1/5 my age? They would be x over 5. And a little bit of a complicated one here, but we can still do it. How old is somebody who is 35 years younger than someone who is twice my age? Well, twice my age is 2x, and then 35 years younger would be minus 35. So we can write all of these different things. They're called expressions, officially, with the letter X, to represent how old I am. But can you actually calculate how old I am? Well, no, I've not given you enough information. Just to answer that question, no, I haven't. But what if I told you that somebody who is 101 years old is 35 years younger than someone who is twice my age? Now you could work it out. See if you can. But before we do that, just to bring back an idea that you've probably seen in elementary school before, is that this is a balance, first of all, and we like to use this to represent equalities or equations or anything that is equal. If I put something on this side, I have to put something on this side that has the same mass so that it doesn't tip the scale. In other words, they're equal. So if I put the number 8 over here, another way to put it is 5 over 3. These are in balance. But if I change this to 5 plus 4, then this side becomes heavier and the balance shifts in that direction. What if I have 11? Well, I'm just going to make this up. I'm going to add a number to this side, let's say 8. Well, if I add an 8, it shifts the balance in that direction. So I need to add an 8 to this side as well to make sure that I keep this thing balanced. That's the most important rule. In math, when you're using a balance, or in algebra, when you've got an equation, you can do whatever you want to one side, but you have to do the same thing to the other side. You have to keep this balance. So without the illustration, here's another example. 4 equals 4, obviously. But let's do something to this 4. Let's add 8 to it. Why not? Well, if I add 8 to that side, I've got to add 8 to this side. So now we've got 12 on either side. Yeah, I changed the number, but that's okay. What I really need to maintain is just making sure the left side equals the right side. Let's, I don't know, divide it by 6. Well, if I divide this 12 by 6, I got to divide the other side by 6. That's going to give us 2 on each side, so we're still equal. Let's do something else to this. Let's, this you may remember means multiply. When you see a bracket right next to a number, it tells us that we are multiplying. So let's do 2 times 11. Well, if I'm going to times by 11 on that side, I have to times by 11 on that side. So I'm going to get 22 on either side of the equal sign. And we'll do one more operation here. We'll take away 17. Well, if I take away 17 on the left, I have to take away 17 on the right to maintain that equality. And we get 5 equals 5. So we're going to do this algebraically. Now, when I showed a bunch of you this, I gave you this little simple equation, x plus 3 equals 10. And a lot of you found the value of x right away without writing anything down. And that's great. But what I'm going to show you to do is how do we approach this algebraically? How would you show your work if I asked you to show your work? So the big rule to remember in algebra is that when we've got an x or any letter that we don't know, we want to get it by itself. Right now, it's not by itself. There's a plus 3 with it. We want it to be alone on one side of the equal sign. So what we are going to do to this is we are going to bring in the opposite of plus 3. Well, the opposite of plus 3, you may have guessed, is minus 3. That is going to get the x by itself. But if I do a minus 3 on the left, I have to do a minus 3 on the right. So if I do that, I'm left with x plus 3 minus 3 equals just x. 10 minus 3 is equal to 7. There you go. Now, a lot of you probably figured out that this was 7 before you even did anything. But to show your work, you would show yourself subtracting 3 from the left to get the x by itself and subtracting 3 from the right because you have to do that. Next, this is telling me that I don't know what y is. Some of you can figure this out before doing anything. But 8 times y equals 72. I got to get the y by itself. And to do that, to get something by itself, remember what I said before, you're going to do the opposite of what you see. So 8 times y. What is the opposite of 8 times something? Well, it's dividing something by 8. So I am going to divide the left side of this equation by 8. But that means I also have to divide the right side by 8. Here we've got an 8 divided by an 8. Anytime you've got some number divided by itself, it becomes just 1 or 1y. We don't even have to show the number 1, to be honest. We can just write y equals 72 divided by 8. And that gives us 9. You may remember back in class when I've got something on the top of a fraction or a division and the same thing on the bottom, I can just cross them out together like this. Here's one more example. Z over 9 equals 3. So you can probably figure out the value of z by just looking at this. Some number divided by 9 has got to be 3. But let's do what we did here already. Let's get z by itself. Well, we've got a number divided by 9. The opposite of dividing by 9 is multiplying by 9. Remember, that's what these brackets mean. So 9 times z divided by 9, we'll cancel that out. But wait, I got to multiply this side by 9 as well. So we cancel out these 9s because 9 times z divided by 9 is going to be just z. And 3 times 9 is 27. So that is your goal in algebra. Get the letter or the symbol, whatever you're working with, by itself. And what you're going to see also is some word problems. These are actually very similar to word problems you have already done. And you don't even really need to be that familiar with algebra to do them, but we are going to answer these by working with algebra. So it says a teacher will be 64 years old in 17 years. How old is the teacher right now? You can probably figure this out. But let's write an algebraic equation, meaning let's write something with the letter x. So x will be how old the teacher is, plus 17, and that will get us to 64. So same thing that I did before. I want to get that x by itself. I've got a plus 17. What's the opposite of plus 17? Well, it's going to be minus 17. So if I do that to the left, I have to do that to the right. X plus 17 minus 17 is just x. And 64 minus 17 is 47. That's not my age, or is it? I don't know. You have to stay tuned to the end of the video to find out. Next question. A square has a perimeter of 114.8 centimeters. What is the length of one of its sides? Well, you know how to do this if you've been working with the perimeter of a square. You can figure this out, but we'll do it one more time algebraically. We're going to say I'm using a smiley face instead of an X here. That's okay. I can use whatever symbol I want. It doesn't matter. 4 times smiley face equals 114.8, which is the total perimeter. I got to get the smiley face by itself. And because I'm multiplying it by 4, the opposite of multiplying by 4 is dividing by 4. That means I got to divide this side by 4 as well. These 4's go away, and I'm left with just the smiley face by itself, which is what I wanted. That is going to come out to 114.8 divided by 4. I get 28.7 centimeters. Yes, you are allowed decimals in algebra. There's nothing wrong with that. We'll do one more little example today that's a little bit more complicated. Here it says 12 out of 20 students are girls. How many girls are there in a school of 1,280 students? Well, you can already solve this. This is a cross multiplication problem, but the way I'm going to do it is I'm going to build my little cross multiplication and solve it algebraically. Well, I've got 12 out of 20 students that are girls. I'm writing in the words here just to help me keep this organized. So 12 girls out of a total of 20 students. For an entire school, I'm trying to find out how many girls that is over 1,280 students in total. The big thing when you're setting up a cross multiplication, remember, is that if I've got girls on top here, they have to be on top over here. If I've got students on the bottom here, they have to be on the bottom here. You have to be consistent. Okay, and a lot of you remember how to solve this, but just to show you algebraically, well, first I got rid of all these words just to make it a little bit easier to read. You may remember when I've got a situation like this, I take the two diagonal numbers, 1280 and 12, I multiply them, and then I divide by 20 to get the answer. But let's do this one algebraically. I've got x divided by 1,280, and I want to get x by itself. So the opposite of dividing by 1,280 is multiplying by 1,280. And if I do it to that side, I have to do it to this side as well. So that is going to get rid of the 1,280s on the right. And that means I'm left with just x. So x is equal to, what do I have over here? 1,280 times 12 divided by 20. Here I am just writing that out again. And that is the original cross multiplication that you may have done. If you do this, you're going to get the answer of 768 girls. One more question like this, which is a little bit trickier. It's saying that there's a bag of marbles containing 399 marbles. Some of them are green, some of them are blue. And what it tells you is there are 3 green marbles for every 4 blue marbles. Just be careful when you build the ratio for this one, or when you set up your cross multiplication. It's not 3 over 4. What it's saying is that there's 3 green marbles for every blue marbles. Here's a little picture if this helps you visualize it. It's saying that every time I encounter this many marbles, 3 of them will be green, 4 of them will be blue. So if I want to make a fraction to represent each color, well, for blue, there's 7 total, 4 of them are blue. For green, there's 7 total, 3 of them are green. So be careful, it's not 3 over 4, it's 3 over 7. Just be careful when you set up that cross multiplication, as I said. So that is what we're going to use. 3 green over 7 total is equal to X amount of green. I don't know how many, over 399 total. And you can cross multiply this, but we're going to do it algebraically. It's ultimately the same thing. And what we'll do is we will do, 399 times 3 divided by 7. But let's get the x by itself. X divided by 399, the opposite of dividing by 399 is multiplying by 399. That means we got to do it to this side as well. So now we have gotten the x by itself, and it is equal to 399 times 3 divided by 7. You should get 171. So there you go. These are situations that you've already seen, but now we're doing it with the idea of getting the x by itself. That is the big rule in algebra. And it's very important that you get comfortable doing that, because as we go further and as you head into Sec 2, the equations in algebra are going to get more complicated than what you see here. But if you remember this idea of getting x by itself, you will be good to go. So your job, if you're watching this video, is work on questions 1 to 20 in this little work package that was emailed to you along with your planner. And if you haven't completed the test that is up on the website that was also mailed to you, please make sure you do. It does count. So remember, you get a pass or fail for term 3, so I need to see that you have done the work. So thank you for doing it if you've already sent it in. And that's it for today's video. And oh yes, as I promised, I'll reveal my age. I am exactly